एक्सक्यूज मी सर, आपका माइक म्यूट है।
Thank you for indicating that. Sorry for that. So handoff is necessary when a user is using any services from the network, either voice or data. And during that, it is moving from one base station to another. So in that movement, while on services, whether it is while on call or while on data, and moving from one base station to another base station, it should be handed over from its old base station to the new base station where it is moving. And it is managed by the MAC that triggers this handover. There are different levels, maybe BAC involved, sometimes BAC only involved, MAC is not involved, but MAC has information about the handoff anyway. So handoff operation is based on two things. One is identifying a new base station where a mobile station is moving. And second one is then reallocating the voice and control channels depend on the services, what services a user is using. Based on that, those channels should be reallocated with the new base station. So the resources from the old base station should be released, and the resources from the new base station should be occupied or allocated to that particular user. So the question is when to start this handoff. So basically it depends on the power handoff threshold or the power values. There are two powers. One is the actual power that is being received by the mobile station at a given time. Another power is called minimum usable power. That is the minimum power required for mobile users to receive the signal in the acceptable level, or that power level at least required to understand the communication properly. So that we range from -90 to -100 dBm. That is the minimum usable signal power for acceptable voice quality. That is from -90 to -100 dBm. And where to trigger this handoff, it depends on the handoff margin. That is, we say delta. And delta is nothing, it's a difference between actual receive power, that is, we say PR handoff, minus PR minimum stable. Now, PR handoff, why we say handoff? So this is the power. This is the power level where handoff will trigger. And let's suppose we said that this PR minimum is 100 dBm and this PR handoff is set at 150 dBm, minus 150 dBm. Then the difference between the two powers is 50 dBm. Then the delta is 50 dBm. And when the receive power by the mobile station reaches at 150, a handoff will initiate it. So that's why we call it PR handoff. But there is a trick in choosing the size of delta or the value of delta. So delta value is directly proportional to PR handoff, because PR minimum usable is a fixed value. It is either -90 or to -100, whatever it is, but it is a fixed value. It will not vary. We can keep it like -100 or -90. But the PR handoff is a variable. So as it varies, so as the delta. If delta is too large, if we choose delta too large, means we are choosing PR handoff also too large means get too much power, means sufficient power still with the received signals, then unnecessary handoffs burden the mobile station. If it is too small, delta is too small, then there may be insufficient time to complete handoff before a call is lost. So if delta is too large, that means PR handoff or the receive power or the PR handoff that we said, this power may be received by the mobile station. They may not be close to the edge of the base station, may be in between edge and the base station. They are in the mid. So all the users which are in the mid of the cell may be forced to have the handoff due to this large threshold handoff margin. If it is too small, that means users are already at the edge of the base station from they are moving to the new base station, and then there may not be sufficient time to complete the handoff before the minimum power goes beyond the minus 100 dBm. So in that case, delta is too small, and in other case, delta is too large. So in this figure, we have two figures. One is at shown as between the power levels between the two base station 1 and base station 2. A and B points are shown, level at point A and level at point B. So in the second figure, you can see we have proper handoff situation where uh, user a user is moving away from base station 1 and is moving towards base station 2, and it is at point A. Even when it is at point A, its receive power has reduced. And this is the PR handoff, and this is the PR handoff, that is the level at which handoff is made. So when it reaches at this power level, a handoff is initiated. That means the resources from cell 1 needs to be terminated, and the resources from base station 2 needs to be uh, assigned to this particular user. So once the resources are assigned, then again the power will increase as the user moves away from base station 1 and towards point B. So at point B, it is receiving now sufficient power from the base station 2. So this is called properly transferred handover. So handoff must ensure that the drop in the mirrored signal is not due to momentary fading and that the mobile is actually moving away from the serving base station. So that was the first point. If you see, identifying a new base station means identifying there is a need of handoff. It shouldn't be like that. It is just a drop or a fade in the power for just a few micro or milliseconds. So base station or the handoff strategy should make ensure that it is not just a fade. A user is moving certainly from away from that base station and it is moving towards another base station. So how we do that? We calculate the running average measurement of signal strength, and that should be optimized so that unnecessary handoffs are avoided. Depends on the speed at which the vehicle is moving. Steep short-term average, the handoff should be made quickly. The speed can be estimated from the statistics of the received short-term fading signal at the base station. And dwell time is the time over which a call may be maintained within a cell without handoff. And it depends on propagation, interference, distance, and speed. So the first point is that tells us the handoff strategy should make sure that a user is moving away from a certain base station to the new base station. And how we may ensure that we must calculate the running average measurement of the signal strength. From that, we can have an idea that if it is keep decreasing, that means a user is moving away from the base station, but just a fade for few microseconds may not be, may not, should not trigger the handoff if we take the average measurement, because that fade of few microseconds will not alter the average too much, so that we can avoid the unnecessary handoff. So this is how to optimize the detection of need of the handoff. Now this average measurement depends on the speed at which vehicle is moving if user is in the vehicle. So steep short-term average will be used when a user is moving at high speed. The handoff should be made then quickly, because average of a user, if he is on the foot, a pedestrian user, his average will be changing relatively very slow compared to the average of a user which is moving in a vehicle and is moving away from the one base station to another. So that these are two different scenarios. So in that, in one case we use the running average, in other case we use the steep short-term average. So both these two will decide fate of handoff for different type of users. One is pedestrian and one is in the vehicle. So speed can be estimated from the statistics of the received short-term fading signal at the base station. And then we have this dwell time, that is the time over which a call may be maintained within a cell without handoff. So if you know the speed, you can calculate the dwell time of that particular user, and accordingly, you can make very like quick decisions for the handoff, or you try to make handoff very quickly, so that call should not be dropped as the vehicle is moving very fast from one location to another, or from one base station to another. So dwell time depends on propagation, interference, distance, and speed. So from these four parameters, we can calculate the dwell time. Based on that, we will initiate the handoff, and the speed of handoff will depend on this shortness of the dwell time. In first generation analog cellular system, signal strength measurements are made by the base station and supervised by the MAC. And in second generation systems, TDMA, handoff decisions are mobile assisted, which is called mobile assisted handoff. So in 2G, GSM, those are TDMA based handoff decisions are totally initiated or assisted by the mobile itself. So we call them MAHO, that is mobile assisted handoff. Inter-system handoff, if a mobile moves from one cellular system to a different cellular system, that is from so inter-system handoff is when a user is moving from one cellular system to another cellular system controlled by different MAC. That means from one network to another network. Uh, but this scenario will happen maybe not in Pakistan, because in whole Pakistan, a mobile network has the coverage. But inter-system, maybe it is like from a 2G to 3G system. So in our scenario in country of Pakistan, this inter-system handoff may be from one generation to another generation. Like in big cities, we have 3G. So as we move away from the metropolitan cities towards the uh, rural areas where 3G may not be available, we may have the 2G. So there you might need this inter-system handoff. So handoff request is much important than handing a new call. So drop call may hamper KPIs more than not entertaining a new call. So if you are not entertaining a new call, means you are not committing to servicing, uh, not committing to service that new call. But if you have committed to serve a new call and it is in the handoff, so handoff request should be given priority so that it is should not be dropped because you committed to provide full services to that user. Then we have different types of users. High speed users need frequent handoff during a call. Low speed users may never need a handoff during a call. Micro cells to provide capacity. The MSC can become burden if high speed users are constantly being passed between very small cells. So minimize handoff intervention. Handle the simultaneous traffic of high speed and low speed users. Large and small cells can be located at a single location. Then the concept of this umbrella cell, where different antenna height and different power levels. Cell dragging problem. Pedestrian users provide a very strong signal to the base station. The user may travel deep within a neighboring cell. So you might have experienced that when you are in a area like Qasimabad, Latifabad, or Hirabad, where the population is very dense, people are living very close to each other, highly populated areas, you will find that cells are not that tall. Their length or the height from the earth is not that too high. They are not too high. They are like installed on the rooftop of the buildings. If they are on the earth, they are maybe installed at 10, 20, not 10, but 20, 30 meters uh, height. But you also find some cells which are 60-meter in height from the ground. So those uh, cells with the higher height than the other cells are basically uh, you can say the are responsible for the high speed high speed users handoff. Because if we ask or provide this responsibility, give this responsibility to the cells which are not uh, high from the ground. Their main purpose is to provide services uh, to the dense population located around that, provide the capacity. But the handover will be provided by that tall base station that we say that base station is the umbrella cell. So in that we can have the cell dragging problem where pedestrian users provide a very strong signal to the base station. The user may travel deep within a neighboring cell. So this is how it can happen. You can see few base stations. They are not that too high. One base station is too high. Small cells are the little cells in height. They are called small cells for low speed traffic and large umbrella cells for high speed traffic. So handoff for first generation analog cellular systems, 10-second handoff time, and it is in the order of 6 dB to 12 dB. Handoff for a second generation cellular systems, example GSM. It is again of 1 to 2 second time is reduced. Mobile assisted assist handoff, and it is in order of 0 to 6 dB. That is a power drop from the time it is started and up to the point where it ended. Handoff decision based on signal strength, co-channel interference, and adjacent channel interference. Whereas in CDMA spectrum cellular system, mobiles here the channel in every cell, no physical change of channel during handoff. MSC decide the base station with the base receiving signal as the service station. So CDMA based systems are known as universal frequency reuse systems, where we don't differentiate users in frequency. So when we say the handoff, it is just not the frequency or the resources, because a base station is providing the same frequency as the next base station. Only thing is that the code will change from one to another. So the physical change of channel during handoff is not there. So it is just the code that is being uh, allocated new one when a mobile is user is moving from one base system to another in terms of the if it is CDMA. Interference and system capacity, sources of interference. Another mobile in the same cell can provide interference. A call in progress in a neighboring cell uh, can also provide interference if there is a Doppler spread. Other base stations operating in the same frequency band can also give the interference. Non-cellular system leaks energy into the cellular frequency band. Again, frequency dispersion. Two major cellular interference, co-channel interference, and adjacent channel interference. So we will discuss these in detail in the next class. If you have any question, you can ask.